Hi there, guys. Welcome to our new reality. I'm so sorry that things are turning out this way. I know you did not sign up to take an online class, but we are all going to do the best that we can and be a little bit more relaxed about everything. Um, I have decided to skip the rest of chapter 3. It's not necessary, and we can always go back to it at the end of the semester if we have time. I'm still holding out hope that we make it back before the next test, but if we don't sweat it. It's going to be a simple take-home test that I email to you. You do the work, and you either scan your work and send it back to me, or you take really good pictures and send them to me either somehow, preferably in an email. For now, we're going to start chapter 1. We've finished all of the derivatives, and now we're going to learn to go backwards. We're going to do anti-differentiation. So the best thing to do is start at the basics with notation. The notation is really, really, really important, and it gets more important as we move through. So what we've done so far, we knew that dy dx, that's one way to write a derivative, is the same thing as f prime of x. So now we know that the differential of y is the derivative of the function times the small change in x. I know it doesn't really make any sense right now, but just wait. This symbol is called an integral. We are going to integrate, in other words, find the antiderivative of both sides of this equation. And this is the way you will see most of your questions written. We have y equals the integral of some function that is actually the derivative of some function y. What we have to do for all of this chapter is take this whatever is this is called the integrand, the thing that you're integrating, and we have to figure out what was the function before the derivative was taken. Alright, so let's see if I can squeeze all of that up here. Alright, so let's look at something that we've done before. If we know that y is, let's say, 3x squared plus 2x minus 5, and we took the derivative of this, what did we do? Well, first we multiplied the power. We multiply whatever the power of x is, multiply that down, and then we subtracted 1 from the power. Now we don't write x to the 1, but you can see what happens, right? The next term, 2x to the 1, we're going to take the 1 power here and multiply the 2 by that, which gives us 2. And now what's the power on x? Up here the power was 1. When you subtract 1 from that, you get x to the 0. Well, what's x to the 0? X to the 0 is just 1. So he's not there anymore. And now what about the derivative of the constant? This guy right here. Remember, derivatives are rates of change. And if negative 5 is always negative 5 and it never changes, then what's its rate of change? 0. But another way to look at it is that if we have a constant, we have the constant times x to the 0. Now, if we took the derivative of this, a power rule derivative, we would take that 0 and multiply the 5, right? So we would get 0x to something here. So when you took the derivative of a constant, you remember that that guy went completely away. And that's important to remember when we're going backwards. So this derivative has a 0 at the plus 0 at the end of it. Now what if we go backwards and we say that y, sorry, hold the phone. And we say that y is the antiderivative of this function, which is now the derivative of something. And we're going to go backwards. Now, what did you do? I'm sorry, I'm just learning here. What did you do when you went from here to here? You multiplied by the power, and then you subtracted 1 from the power. What's the opposite of that? Go backwards. If you go backwards, do you divide and then add, or do you go in the opposite order as well? So now what we have to do is first add 1 to the power, and then the opposite of multiplying will be divide by the new power. When we do this, we'll see that we get what we started with back again. Oops, sorry. This is going to be rough for a little while until I get the hang of this. So y equals, we have 6x to the 1, but we're going to add 1 to the power and divide by the new power. Then we have plus 2. X was to the 0. We add 1 to that, and we divide by that. So you see what we have is 3x squared plus 2x, but wait a second. The original function had a minus 5. Do you remember that? Well, anytime you take an antiderivative using a power rule, and I'll write down the power rule in just a minute, anytime you do this, you have to wonder if there might not have been a constant right there. But when the derivative was taken, it was plus 0. Remember? So if we go backwards with that plus 0, when we take the antiderivative or the integral, then we have to allow for that possibility that there was a constant, okay? So this guy is called a constant of integration. So anytime you do an integral and you're not doing it on a definite interval of x values, we'll talk about definite integrals later on, but anytime that you're just finding an antiderivative, you have to stick that possibly constant term in there. So we just say plus c at the end of our integrals. All right? Whoops, this isn't working here. I'm trying. That's good enough for me. Good enough for you? Let's move a little faster here. Okay, try this one. what is the integral of x cubed minus 4x squared plus 3x minus 8? That dx is the differential of x, and it has to be there. It's an operator that works in concert with the integral to give you an antiderivative problem. So don't forget the dx. He's very important, and he's going to get even more important later on. So let's see what we're going to do. I'm going to copy my x, increase the power, divide by the new power. I'm going to copy my minus 4, my x, I'm going to add 1 and divide. Copy plus 3, copy the x, add 1 to the power, divide by the power, copy the minus 8, that was x to the 0. We're going to end up with x. Let's think about this. What's the derivative of x squared, of 8x? The derivative of 8x is just 8. So you see how that works. And we always allow for the plus constant there. And then you make it pretty. I'm not going to make you find common denominators or anything. I'm running out of room here on my board, so I'm going to be a little bit messy down here. Nothing cancels? Well, I'm wasting my time then. Never mind. None of those fractions reduce to lowest terms, so you just always make sure that your fractions are reduced. Are we good? So let's talk about some rules. I'm going to give you more than just a rule here. First, power rule integral. If we have the integral of some number, some variable to some number power, we're going to add 1 to the power and divide by the new power and allow for a constant of integration. Now, what if we were integrating just some constant? We'll call him k. If all you have is a constant, remember that that is, there's an x to the 0 right there. X to the 0 equals 1. So you're integrating x to the 0 power. When we do this integral, the k is there. We copy the invisible x. We add 1 to the invisible power, and we divide by 1 plus c. Now, ask yourself, what's the derivative of k times x? It's just k. So we know we're right. You can always take the derivative of your answer and check to make sure that you get the question back. Okay, a couple other rules that are in 4.1 that I wish were put a little bit later, but they are in this section, so we are going to do these. Remember, the derivative of e to the power is e to the power times the derivative of the power, right? So when you're going backwards, you still have e to the number x, but we need that number in the bottom. Think about what this means. I'm going to put a little thought bubble over here. Let's do the thought bubble in red. If I have y equals e to the 3x, then the derivative of y is copy e to the 3x, but then I have to multiply by the derivative of the power. So if I integrate 3e to the 3x, which is my derivative here, then I'm going to keep the 3. He's going along for the ride. I copy the e to the 3x, and I divide by the 3. You see how the 3's will cancel, and we get the e to the 3x that we started with way up here at the top. You see that? So that's why you have to divide by the n. When we get to integration by substitution, which is in 4.5, we'll understand this a lot better. All right, let's try the homework at this point. For 4.1, you can stop this video and you can try the homework in 4.1. Whoops. 4.1, all of the homework is 1 through 55 odd. Now I know we're in a new space here and we're not used to doing lectures and things in this way, and I know you can't ask me any questions, but once you watch this video, if you'll scroll down, you'll see there's a comment section, but there's also the Hangouts app, which is going to be really handy for you guys if you'll just download that app on your phone. I know we don't need any more apps on our phones. I don't, but I've had to download a whole bunch of stuff to get ready for what we're doing here. But if you download the Hangouts app, you can send me a text at MAF35 at email, just like yours, email.vccs.edu. If you text me there, I get it instantly. I'll get back to you quickly. And if you really need to meet with me, we can meet on Zoom. And I'll help you figure out exactly how to do that if you haven't done it yet. If you have done it, you know that it's easy. And that once you've met with me once, all you have to do is click the Zoom tab on your Canvas, and you should have Canvas on your phone. Get that app as well. Click Zoom and go to all of my meetings, and my office hours meeting will show up. All you have to do is hit it once you have texted me and let me know so that I can open the meeting. Please, I beg you, stay in touch with me. Don't get behind. In a few minutes, I'm going to make another video where I'm working out some of these example homework problems from 4.1 so that you can see exactly what I'm doing. We're going to skip 4.2 and head over to 4.3 after that. But get this homework attempted and completed as quickly as possible, and watch for my next video. Bye.